Upthrust.
Upthrust.
Uh,
Yeah, what is
Perpendicular upward force acting on an object which is immersed in a liquid.
Okay, perpendicular upward force acting on an object which is immersed partially or wholly in a liquid. So that upward force is called as upthrust. Okay. Perpendicular upward force acting on an object. So this upthrust or buoyant force, it acts on objects which are immersed in a liquid. All the objects which are immersed in a liquid, they experience an upthrust. Okay. So not all the objects, only the object which will be immersed in a liquid or fluid. So this is the property, you can say this is the property of the fluids. Okay. The property of the fluids to exert an upward force on the objects which are immersed in them is called as upthrust or buoyancy. So buoyant force up or upthrust. So that means now let us do an activity with this. Okay, I think this was the chemical formulation that I did with you yesterday. It was by mistake. By mistake, it was not yours class. It was class 10th down.
Yes, sir.
Right?
It was class 10. I was searching the chapter
Yeah.
and I found it in class.
Yeah. No, actually, a student messaged me that I have this doubt, so I thought it's from your class, and I just forgot it is class 9. Okay, so that's why the problem was there. Now see, we have upthrust or the buoyant force. See what? How can we calculate the upthrust? Let us consider a liquid in a jar. So you have a jar, and in this jar you have a liquid. Let's add some liquid to it. You have water, suppose. Now we take a wooden block. Let's take a wooden block and measure its weight outside. So here we use a spring balance. We use a spring balance to measure its weight. So here we measure the weight of this block outside this water. Let's say here it has the weight W, right? It has the weight W which is being measured by the spring balance, right? Now if I take this block and immerse this in water, I take this block and I immerse this block in this water. So what will happen in this water? When this block is immersed in water, if you have this block immersed in water, okay. So see, what are the scenes, what are the different forces that are acting on this? Again, its weight is acting in the downward direction. As we know that weight is also a type of force. So a weight is acting in the downward direction and an upthrust is acting on this in the upward direction. Okay. Now, if both the forces will be equal, so what do you expect? Will the mass or will the weight of this block decrease or increase when it is dipped in water or when it is immersed in water? Harini, what will happen? Will its mass increase?
Sir, it will not. Sir, I think the weight might decrease.
Weight might decrease. Okay. Siddhisri, what would happen to the weight? Yeah, Siddhisri, what would happen to the weight? Will it increase or
Can you
decrease
repeat
or
again?
will it remain the same?
Can you repeat again, sir?
Yeah, we have a wooden block over here. Okay. See, you have a wooden block which we weigh in the air. Let us say it has some weight W. Now we take that wooden block and weigh that wooden block in water. Immerse that wooden block in water and again find its weight. Find its weight, then means we have not taken it out of water. It's still in water and we find its weight. Okay. So what will happen? What will happen to its weight? Will it increase or decrease?
Will
Decrease.
decrease because of the
Decrease, sir.
buoyancy.
It will decrease.
Yes, sir.
Okay. It seems as if someone is lifting the block in the upward direction, right? It's just equivalent to, suppose here it was in the air and you try to lift it from the bottom. If you just try to lift it up from the bottom with your hand, so this block will get lifted up and hence its weight will decrease. So here if the block is kept in water, its weight will decrease and hence there will be a loss of weight. Okay, so there will be loss of weight. Okay, and that loss of weight will be equal to its weight in air minus the upthrust. Okay, this should be equal to the loss of weight, since upthrust is what is acting in the upward direction. So the loss of weight should be equal to the weight in air, which we denote by W naught, minus the upthrust, right? Got it? Understood this point? What is the loss of
Yes.
weight?
Yes.
Okay. Now, if this block is completely floating on the surface, if it is completely floating on the surface, so do you think that its weight is equal to 0? What will be its weight if it is just floating over here? Will the spring balance show any reading or not? The spring balance will not show any reading. Okay. So that means the weight of the block would be 0. Okay, if the block is floating in air, if the block is floating in water, so that means its weight is 0. Okay, so the weight of the block will be 0. That means the loss of the weight will be equal to the upthrust. Okay, hence it will float. Any object will float either if its upthrust, if the upthrust is greater than, if the upthrust is greater than its weight, then only the object will float, otherwise the object will sink. Got this point? When will the block float or sink? If the weight is greater than the upthrust, then the object will sink. Okay. Now this was one of the points where we have considered the loss of it. Now let us try to see at some other way the same experiment. Now we are trying to understand it the other way. The other way is that we take a block now. So we take again the same beaker. So again we take here same beaker. And in this, let's fill this beaker now up to the top. Okay. The figure, let's even if it is filled up to here, let us say it has a, let's say the beaker has some overflow pipe over here. It has an overflow pipe. The beaker has an overflow pipe over here, so that if any amount of water is greater than this, that water will float out of the beaker, right? Okay, so in this situation, if we immerse this block over here, if we put this block in this water, so do you think that any amount of water will be displaced by it? Will any amount of water will be displaced by it? Or a Smith?
Yes, sir.
Okay, so suppose some water is displaced by it, and of course that water will be equal to the volume of the block which is inside the water, right? Whatever volume of the block is inside the water, that volume of the block will be equal to the volume of the water displaced. Okay. So here you will get some water that will be collected out, and the volume of this water, okay, the volume of this water, volume of water will be equal to the volume of solid immersed. Okay. Any doubts here? Abhinav, understood this?
Yes, sir.
See, we have done the same experiment, but we are looking two things. First of all, we are looking at the block. We weigh the block in air, and let us say its weight is W naught. Then we dip this block in water, and again we weigh here. Let us say now its weight is W. Okay, so it's the loss of weight. We can also write it like this. We can also write the loss of weight as W minus W naught minus W. Just wait for 1 minute, beta. Just wait for 1 minute. Okay, am I audible now? Yes, am I audible?
Yes, sir.
Yes, sir.
So let's continue now. See, what we did in the first experiment, we took the block and weighed this block in air. Let that weight be W naught. We put that block in water and again weigh that using the spring balance. So its weight is W. Hence, the loss of weight is equal to W naught minus W. And here we also observe that when we immerse this block, then there's some amount of water is being displaced out of it, and this is the volume of the water displaced. Now, as per the Archimedes principle, I told you that yes, and in the next class we will be discussing about the Archimedes principle, right? So we had to state here about the Archimedes principle. So as per the Archimedes principle, it states that the loss in weight. It states that the loss in weight of a body, loss in weight of a body is equal to the upthrust. So the loss in weight of the body is equal to the upthrust and is also equal to the weight of liquid displaced. So understood the Archimedes principle now. The Archimedes principle says that the loss in weight, which is equal to W minus W naught. Here we can represent the loss in weight as W minus W, W naught minus W is equal to the up thrust. So this is equal to the up thrust, and it is also equal to the weight of liquid displaced by it. So this is equal to weight of liquid displaced. So understood the statement of Archimedes principle? Chavan, understood this Archimedes principle? Siddharth? Siddharth, have you understood?
Yes, sir.
Okay. So
Sir,
just
can I
I'm
explain
giving.
once?
Yes, sir.
Okay. Who says once more?
Aerosmith.
Okay, Smith. So first understand this activity which we did. There are two the same activity, but we are observing at 2 points. Okay. First of all, we take a block, maybe wooden block, maybe iron block, whatever block you may take. Okay. But if you take an iron block, it will sink. There will also be loss of weight. Okay. If you take a wooden block, there will also be loss of weight. Both of them, they will experience a loss of weight. So how it will happen? First, we measure the weight of this block outside water, and the weight of this block outside the water we measure as W naught. Okay. The same block is now immersed in water. So when we immerse in water, again we measure its weight by using the same spring balance. Right. So by the spring balance, again we measure the weight, and now we find that its weight is not W naught, rather its weight is W. Okay. So there will be some loss of weight, and that loss of weight will be equal to W naught minus W. Is this clear this much?
Yes, sir.
Okay. So its loss of weight is equal to W naught minus W. And why it is also equal to up thrust? As we experience here, that the up thrust is acting in the upward direction. It is the up thrust which causes the loss of weight. Okay. So up thrust must be equal to the same loss in weight of the object is also equal to up thrust. Then when this block is immersed, we also observe that some volume of this is immersed inside the liquid. Okay. Here, since this was the wooden block, so we observe here some part of wood is immersed inside the liquid. If it was a metal block, so we would observe that the complete metal block is immersed inside the liquid, and hence some amount of water will be displaced out of it. Okay. So some amount of liquid will be displaced out of it. Let the volume of the liquid displaced be V. This is the volume of the liquid displaced. Okay. So what the Archimedes principle says, that the loss of weight, that is W naught minus W is equal to up thrust, and also this up thrust is also equal to the weight of liquid displaced. Whatever liquid has been displaced by it, we collect that liquid, and if you weigh that, so weight of this will be equal to the up thrust.
Sir, can you give us a question on this to see if we
Yeah,
get
I'm
it?
giving a small question. Just write down. Try to solve this question. An iron ball, okay, an iron ball weighing 60 gram, okay, an iron ball weighing 60 gram in air is dipped in water dipped in water. It displaces water equal to it displaces water equal to 20 gram weight. So your questions are, you have to find upthrust, acting on the block. So what is the upthrust acting on the block? Then second point, you have to find what will be the weight of iron block in water. So you have to find the upthrust acting on block. Second thing, you have to find what will be the weight of iron block in water. Okay. So this is again 60 gram weight. Think of this. I'm giving you 2 minutes to think of this. And then I will start solving with you. Think of it. What are the things that are to be done? Yeah, Harini,
Yes, sir.
have you got the answer to the first question?
Sir, I did a small calculation error, so I'm doing that question again.
Okay. If you just remember the Archimedes principle, the statement of the Archimedes principle. Okay.
So the volume disposed at if the water is equal to the volume of the object.
That is not the statement of the Archimedes principle. Again, that's what I'm saying. See the statement of the Archimedes principle. See the statement of the Archimedes principle
Sir,
first.
I think,
Hmm. The
sir,
statement
I
is
think it is 60 minus the,
yes.
Sir, I think it is 60 minus.
Answer to the first question. What would be the
I
answer
think
to the
the
first?
thrust is. Sir, it would be 40.
40. Okay, just see.
The second one would be 40, right?
Okay,
Sir,
so
the
that's
second one will be 40.
okay. Here is a question. For your help, I am putting the Archimedes principle also here. Okay. For your help, just have a look at the Archimedes principle also.
Sir, I got it.
Abhinav, did you get the answer?
No, sir, it's did not understand the question.
Okay, see.
Like, find out the stuff.
Okay, see. First of all, things which are given and the Archimedes principle. As per the Archimedes principle, you have loss in weight of the body is equal to upthrust. Okay. So mark these points. Loss in weight of body is equal to upthrust. Right? So here the question says an iron ball weighing 60 gram weight in air is dipped in water. So we know that W naught, which is the weight in air, is 60 gram weight. This is 60 gram weight. And it displaces water equal to 20 gram weight. So what is the weight of water displaced?
20.
Weight of water displaced is equal to 20 gram weight. Right? So loss in weight of body is equal to the upthrust and is also equal to the weight of liquid displaced. So see here, we have the weight of liquid displaced. the weight of liquid displaced is 20 gram. Okay. And it should be equal to the upthrust. As per the Archimedes principle, the weight of liquid displaced should be equal to the upthrust. Okay.
So
So
that's
hence
the first answer, right?
yeah. So your first
Okay.
answer would be just 20 gram weight. Your answer number one would be 20 gram weight.
Where did you look at my second answer?
Second answer would be 40 gram weight.
Yeah, you looked at mine, right?
Yeah. Second answer would be 40 gram weight. Okay. So everyone has understood this problem? Siddharth, you got your mistake?
Yes, sir.
Okay. See, the upthrust is, we know that upthrust is 20 gram weight. And from here we know that upthrust is equal to loss of weight. That is W naught minus W. So upthrust is 20. It is equal to W naught, which was 60 minus W. We want to find out W. So transpose the terms. You will get W equals to 60 minus 20. This would be equal to 40 gram weight. Okay. So I hope everyone has understood this question. Harini, you understood the question?
Yes, sir, yes.
Okay. So the statement of the Archimedes principle is very important. Understand the statement that the loss in weight of a body is equal to the upthrust and is also equal to weight of liquid displaced. So any doubts? Shall move further. Okay. So now we will see one more problem. Just one more problem. And I think you will be able to get this. Okay. So here we have an iron ball, so and a wooden block. Let's say a wooden block of weight a wooden block weighing 20 gram in air. तो अब मुझे समझते हुए बैठो लगा देंगे a wooden block of weighing 20 gram weight in air floats in water. So it floats in water. A wooden block of weighing 20 gram weight in air floats in water. So you have to calculate here what will be the weight of liquid displaced. Weight of liquid displaced. Okay. So what would be the weight of liquid displaced that you have to tell? Then the second question is what is the loss in, what will be the weight of block in water? Okay. So what would be the weight of blocks in water? These two are the questions. Also, what is the value of upthrust? बोलो क्या? Equal. Okay, what will be the value of upthrust? So these are the questions. Solve these questions, and if you have done, give your answers in the comments. Give your answers in the chat section, not in the comments. Your answers should be in the chat section, right? So everyone, I'm waiting for your answers. Yeah, so any answers is anyone has done? I have not got any answers up to now. So see, when the wooden block is floating, okay, it is floating. So what weight would it show on the spring balance? What weight will it show on the spring balance? This is your first question. You have second question, and you have the third question. Right? So what weight will it show on the spring balance?
0.
0. So what is the value of the upthrust that we can calculate? What will be the weight of the block in water? So that would be equal to 0. Right? We have got the answer to the second one. The weight of the block in water would be 0. Smith, are you getting?
Yes.
Okay. Since it is floating completely, so its weight will be equal to 0. And remember, I told you that when you are swimming, at that time, you feel weightlessness, right? So here the wooden block is also swimming and it is experiencing weightlessness. Its weight is 0. So weight of the block in water is 0. What will be the weight of liquid displaced? So weight of liquid displaced will be equal to the loss in weight. And here we observe that the loss in weight is 20 gram weight, right? Since initially it weighed 20 gram and now its weight is 0. So the loss in weight is 20 gram weight, and that is equal to the weight of liquid displaced. What is the value of the upthrust? So upthrust is also 20 gram weight. Okay. So any doubts?
No, sir.
No. Okay. So that's good. Now let's see another thing. We have understood, and once more, do not have any doubts. Once more, we will be discussing about this flotation. We will be discussing about the Archimedes principle. I will give you an idea of Archimedes principle once more. Okay, just to have a revision of this. Now we understand another term, that is mass density. Here we take another term which we call as mass density, or mass density. So what do we mean by the density of a substance? The density of a substance, it refers to the mass of substance per unit volume. The mass of a substance per unit volume. So the mass of a substance per unit volume is called density. Now here what we are going to understand about the mass and density. See, the very confusing question that many people might have asked you, and maybe sometimes you also have got confused regarding that. That is, if you take here that same question, even I am asking to all of you, you have 1 kilogram of cotton, okay, and you have 1 kilogram of iron. So which one will weigh higher? 1 kilogram of cotton and 1 kilogram of iron. So which
Sir,
one will
it's
weigh?
the same.
Sir, both
They
are
are both are same. Both will weigh the same.
Yes, sir.
Okay. So what is the difference between them? Is that cotton will occupy more space. It has a greater volume.
Sir, cotton will occupy more space.
Yeah, and iron occupies less space. Iron has the same mass in a little volume, whereas cotton has the same mass in a larger volume. Right? What will happen if I take the volume of both of them to be the same? If I take the volume of cotton and volume of iron to be the same, so
Then
which
the
one
weight
will
will
be?
be different.
Then the weight will be different. Okay. So if I say here, I take the volume, as you know that the volume is measured in meter cube. See, if I take 1 meter cube of cotton, I take 1 meter cube of iron. So which one will weigh more? Friends, which one will weigh more? Which one will have a greater weight?
Sir, iron.
Iron will have a greater weight, as both are confined to the same volume of 1 meter cube. And 1 meter cube, when we say 1 meter cube, it means uh, a volume equivalent to a cube of side 1 meter. If you have a cube of side 1 meter, so the volume of this, okay, the volume of this cube, it has the side A. So whatever space this cube is occupying, or whatever amount of liquid can be filled in this, or whatever amount of cotton can be filled in this, so that volume is equivalent to 1 meter cube. Okay. If each side is 1 meter, so its volume is 1 meter cube. Okay. Now let's have okay, what will be the SI unit of meter cube? SI unit of volume. SI unit of, sorry, not volume. SI unit of density. SI unit of density. This is mass per unit volume, and hence it will be kilogram per meter cube. Okay. The SI unit of density is kilogram per meter cube. We measure the mass in kilogram, we measure the volume in meter cube, and hence the SI unit of density would be kilogram per meter cube. Okay, so the CGS unit of it, if you see the CGS unit, okay, let's try to solve one question. Here you have, write down a question. The density of mercury is 1300 kilogram per meter cube. It's per meter cube. The density of mercury is 1300 kilogram per meter cube. What will be the mass of a cube mass of mercury contained in a cube of so what would be the mass of mercury contained in a cube of side 10 centimeter? Try to find out the answer to this. Okay, anyone obtained the answer? I will be checking the answer for everyone for this question.
I'm almost done.
Okay.
Sir, is the mass 1.3 kg?
Mass 1.3 kg.
Yeah, sir, I got the same 1.3 kg.
Okay, so the mass would be 1.3 kg. In
Yes.
a cube of size 10 centimeter, it will have a mass of 1.3 kg. Right. So let's hear another question. And let's see who is able to do this one. The density of water is so the density of water is 1 kilogram per meter cube. Okay. Convert it to CGS unit.
With CGS for function.
CGS means gram per centimeter cube. You need to convert it to gram per centimeter cube. This is your question 1 and 2. Okay. If anyone is not getting, just inform me. I will be solving the questions which you are not getting.
Sir, I'm not able to do it.
Abhinav, you are not getting?
Yes, sir.
Okay, which
Yes,
one?
sir,
The first one or the second one?
The second one, sir.
Second one. Is there anyone who has not got the answer to the first question?
Sir, I got
And-
the second one.
Okay.
But
See,
I
for the
think it's,
second, for
it's
the
very
second,
small, sir. It's 0.001 gram centimeter cube.
okay, let's see here. The value of density is given. We write the density as equal to 1 kilogram per meter cube, right? To convert it to SI unit, we need to convert this kilogram to gram and meter to centimeter. Okay. So 1 kilogram is equivalent to 1000 gram, right? And 1 meter is equivalent to 100 centimeter.
Yes, sir.
Okay. So if you convert this, you will get very small value. But here, this is not for water. Just erase this for water. For water, this is not the density. For water, the density is 1000. So if you
That
if you take
will
it
be
for
one.
water, yeah, for water it is 1000 kilogram per meter. Okay. So solve this question now for taking the density of water as 1000 kilogram.
So then if you convert it to, okay. So
The density of water is 1000 kilogram per meter cube. Convert it to the SI unit.
is the answer 1 gram per centimeter cube?
Yeah, the answer is 1 gram per centimeter cube. So who else has got the answer? You take this 1000 kilogram per meter cube, convert it to gram per centimeter cube. So 1000 kilogram would be 1000 multiply 1000 gram, and similarly 1 meter would be equal to 100 centimeter and a cube of it. So this would be equal to 10 to the power 6 gram divided by 10 to the power 6 centimeter cube, and hence you will get 1 gram per centimeter cube. This is the density of water. Understood this? Understood?
Yes, sir.
Abhinav?
Yes, sir.
Okay. So try to solve this question. So this one is a question of mathematics, not even of physics. You can solve this quickly. The density of water is 1 gram per centimeter cube. What will be the mass of 50 centimeter cube of water? So solve this. After this, we have another concept, that is relative density, that we will be doing in the next class, or if you have time, we can do right now. Complete it quickly.
Sir, I have to go to another class now.
Yeah.
Sir, I have to leave now.
Okay.
Can I leave?
Yeah, sure. The class is getting over.
So is it 50 grams of water? Will
50
be
gram. Yeah, that would be equal to 50 gram of water.
yes.
Okay. So next one is the ratio of density of a substance with density of water. Is called relative density. So this is another concept. So what is relative density? The ratio of density of a substance with the density of water is called relative density. So we measure relative density as the ratio of the density of substance. Here we have the density of substance. This is the density of substance divided by density of water. Since relative density is the ratio of two densities, it does not have any units, no units. So we will discuss about this in the next class. Okay. Bye everyone. Good night.
Bye, sir.
Bye.
Thank you. Bye, sir.